On the streets, my brother's dying, and I hear the mothers crying, crying out, and the way that things are.
I never present myself without acknowledging the people who made me who I am, my family for their love and support over my first 52 years, and my lab family, the students and scientists that have participated in the work that I'll talk to you about today. I also want to acknowledge my funding sources over the last 30 years, and this is also my disclosure. I became interested in and introduced to this issue by Novartis, Syngenta, the pesticide companies. I have been funded by them, and I have had support, although not anymore. And now I want to take us back to 1945, to the end of World War II. And I want to take us back there because this is really where the problem that we're here to discuss all started. In World War II, there was enhanced technology to capture the energy in nitrates in order to make bombs. And after World War II, that same technology was used to capture the energy in nitrates to produce synthetic fertilizers. So I want to remind you that this was done invented as a matter of destruction and still can be used as destruction, such as in the Oklahoma City bomb in the United States, where fertilizers were used to bring down this building. The other technology that came out of World War II, out of 1945, was the use of pesticides that were developed primarily during the war for the purposes of again, death and destruction. I want to remind everybody that the side part of pesticides, that word means to kill. So a pesticide is specifically a chemical that is designed to kill pests. But like any destructive device, it does not always hit its target. It can hit non-target organisms. So effectively, we're really talking about biocides. And when we're talking about agriculture, the important pesticides are insecticides. These are chemicals that are designed to kill insects that would otherwise kill and reduce the crop yield. We're talking about fungicides, chemicals that are designed to kill fungi that would otherwise decrease yield and kill crops. And finally, we're talking about herbicides, chemicals that are designed to reduce the growth of plants, so-called weeds, that would otherwise take away energy, fertilizers, for example, that are meant for the crops that we're trying to grow. The problem starts with how these compounds are applied. The soil is obviously contaminated with these biocides in the way that they're applied, but also keep in mind that many of these chemicals can volatilize and contaminate the air and can travel in clouds in some cases, up to 1,000 kilometers from the point of application. In addition, some of these pesticides are applied airily, so they contaminate the atmosphere and the environment, and we also have to deal with problems of so-called drift. These chemicals don't just go in the crops where they're sprayed, they drift off into other areas, not just in the crops. And finally, this is a slide from Lake Nabogabo in Uganda, where I used to work. Water ultimately ends up contaminated because of the contamination of groundwater through soil and the direct movement of pesticides to surface water. This slide demonstrates that problem. I run off from this crop. Oops, this seems to not be working now. Oh, the runoff from this crop, in this case, is collected as water and used as the sole source of drinking and cooking and bathing water for this nearby village. So not only is the wildlife exposed to any chemicals that might be used in this situation, but the ground, the soil, the air, and the water are contaminated, and thus humans as well as wildlife are contaminated by consumption of that water. So again, I want to remind you, this is a slide from Salinas, California, where I live, where in some cases, 50% of the U.S.'s food is grown in my state. But I want to remind you with this sign that we are talking about biocides. We're talking about chemicals that are designed to kill things that are sprayed on our food, not only impacting the plants themselves, the food themselves, but the consumers, the wildlife, and especially the farm workers who are exposed directly. To go back to World War II, one of the big chemicals that came out was DDT. DDT was shown to effectively kill insects and protected soldiers in Europe against diseases like the plague that were carried by fleas and this insecticide killed them. It was immediately introduced around the world, including in the United States, where it was used in agriculture and the production of domesticated animals. But we very quickly learned that this compound caused severe damage, in particular, eggshell thinning in birds, but also we now know is associated with cancer, infertility, and hormone problems, so-called endocrine disruption, which I will talk to you about later. Another example from World War II and from this era was the use of Agent Orange, an herbicide that was specifically used to destroy crops in Southeast Asia and to defoliate forested areas. We now know that this Agent Orange caused severe damage and birth defects in children that were exposed, especially in Vietnam. Yet this chemical, 2,4-D, and another component of Agent Orange, is still used right now around the world in agriculture. And let me clarify, I'm not implying that 2,4-D, the so-called active ingredient, caused the deformities. It was the entire mixture itself that caused the deformities. The point is, we're still using ingredients from what we know to be a deadly chemical on our food, and our agriculture and farm workers are thusly exposed. It's not just these old chemicals from World War II, from 1945, that are causing problems, but there are chemicals like the nicotinoids, which are supposedly insecticides that were synthetic, that were supposed to be safe, that we now know are involved, if not the sole problem, with bee collapse. And it's not just the bees that are dying. As you all know, bees produce more than honey for us. They're required for the pollination of many of our food crops, many of our fruit crops, and so we would really be in big trouble if this problem continued. Another example is Roundup. Again, a fairly new herbicide that supposedly is safe, but as many of you know, the first of many lawsuits, and this is Wayne Johnson, who is back in California, has been based on the finding that glyphosate causes cancer, in this case non-Hodgkin's lymphoma, yet it is still the #1 used herbicide in the world. And finally, my involvement with a chemical from 1958, Altrazine, has shown that many of these pesticides are endocrine disruptors. In addition to killing plants, Altrazine is one of those endocrine disruptors. They can cause unexpected and unintended problems. An endocrine disruptor is a chemical that mimics hormones or interferes with hormone synthesis, transport, action, or degradation. And via that mechanism, these chemicals can cause many unpredictable problems based on how they kill the organisms that they're supposed to kill. What's really nostalgic for me is that I came to be involved in pesticide research because I had a dream as a little kid of working in Africa. And about 20 years ago, I got to come to Africa, and I don't even know if you can see it there, to work on reed frogs. That sound you hear at night around the hotel, that's the frog I came here to work on. And I came here to work on, and that particular one was from Nakuru, where I worked about 20 years ago as a graduate student. But I focused my work on the coast, near Watamu, in the Arabuko Sokoke in Kenya, where I discovered another species of reed frog, where the males looked very different from the females as adults. I wasn't interested in pesticides at all. I was just a little boy who liked frogs, who dreamed of doing research in Africa. But what I discovered was the reason that these animals, the males and females, look different is because of hormones. They all start out the same. So this is the same individual when they metamorphose. They all start out green. And the females change color at sexual maturity, at puberty, if you will. So we hypothesized that estrogen, the so-called female hormone, was responsible for these frogs changing color. Don't worry, we'll get back to pesticides in a minute. We tested this hypothesis by literally just dipping these little frogs in hormone solutions in the laboratory. The male hormone testosterone did nothing, as we expected, but the female hormone, estrogen, would cause these frogs to change color. Here's how I got involved in pesticide work, because we patented and we used this frog to detect endocrine disruptors. So literally, here's a control, here's an unexposed frog, they're all green. If we dip them in the natural hormone estrogen, they would change color. If we dip them in birth control pill, human birth control pill, ethinyl estradiol, they would change color. If we dip them in this pharmaceutical estrogen, synthetic, they would change color. If we dip them in DDT, DDT binds and acts like an estrogen. It is an endocrine disruptor to change color. And we showed we could use estrogen blockers to prevent them from changing color. So this little African frog that I was just trying to study its natural history got me involved in pesticides because we figured out we could use frogs in the laboratory to find and determine which pesticides were endocrine disruptors. Then I got asked by Novartis, they later became Syngenta, to review atrazine, the #2 herbicide, the #2 weed killer behind glyphosate. Atrazine, for those of you who don't know it, is mostly used on corn. It's been used since 1958. We use 80 million pounds in the United States. I think glyphosate we use about 120 million pounds. So it's pretty big. And it's used in more than 80 countries. South Africa being one of those where it's very heavily used on corn. While under contract with Novartis and Syngenta, we used another African frog to study the effects of atrazine and determine whether or not it interferes with hormones. This is the African clawed frog, South African clawed frog, Xenopus laevis, and we showed the following. Xenopus, these frogs, make testosterone, the male hormone, just like we humans do. In fact, the word testosterone literally means testicular hormone. It's, quote, the male hormone. We discovered that what atrazine does is that atrazine turns on an enzyme. It turns on the machinery, if you will, that converts testosterone into estrogen. This is working slowly, sorry. Estrogen is, quote, the female hormone. And the consequences are that as a male, you use up your testosterone, so you're demasculinized, and you're subsequently feminized because now you're making the female hormone. And that has some dramatic consequences. This compound atrazine, the #1 selling product for Novartis and Syngenta, emasculates males, not just in frogs. And I'll show you what that means visually. One of the things that atrazine does is it reduces the fertility of exposed frogs. So normally, an African clawed frog will fertilize about 85% of a female's eggs. If you're exposed to atrazine, you only fertilize about 15%. You have a low sperm count. And you have a low sperm count because atrazine knocks out the testosterone. These are what the testes look like under the microscope of a control and an atrazine-exposed male. And if I show you now what this is, I'm going to blow up a section. And I'll blow up a section of the atrazine treated one. And the controls, the unexposed animals, there's sperm in the testicular tubules. But in these atrazine-exposed ones, the testes are devoid of sperm because they don't make enough testosterone to produce sperm. What's more is 22 scientists from 12 different countries joined me in a publication to show that this doesn't just happen in frogs. Here's my work in frogs. My scientists in Belgium showed that fish show the same response when they're exposed to atrazine. A scientist in Argentina showed that a big reptile, like a crocodile, the sperm is missing from the testis with atrazine. Scientists in Nigeria, here's a rat and mammal showing that there's sperm in the testicular tubules. Exposed to atrazine, there's no sperm, and this work was done in Pakistan showing the same effect in quails. So this effect occurs not just in frogs, but across all vertebrate classes of animals, and that should raise concern. Now we can't do these experiments in humans, but my colleagues showed the following. If you look at men in Columbia, Missouri, men who have trouble getting their wives pregnant and have a low sperm count have significantly more atrazine in their urine. So atrazine knocks out sperm in every animal that's been studied. And if you're a human, male, man, exposed to atrazine, you have a low sperm count and can't get your wife pregnant. What's more is, I'm going to change the axes, because what's more is, if you look at the levels of atrazine in men who work in the fields, here are their levels. And if you look at the levels of atrazine in men who apply it in California, they have 24,000 times the atrazine in their urine than men in Columbia, Missouri, that we know have low sperm counts. They have 24,000 times the atrazine in their urine than we use to chemically castrate frogs in my laboratory. Think about that. One of these guys could urinate in a bucket, and I could use the atrazine in their urine to chemically castrate 24,000 buckets of 30 tadpoles each. They're mostly Hispanic, and among that, they have many, many other health problems that we don't address in the United States. And I'll tell you why before we finish. Not only does atrazine emasculate males, it also feminizes males because you're inappropriately producing this estrogen that we talked about. So for example, here's an animal, the insides, the gonads, that was exposed to atrazine that has testes, it has ovaries, it has testes, it has ovaries, which is not how African clawed frogs typically develop. This was caused by estrogen production induced by atrazine. What's more is, this is now a famous photo. These are two males mating. The male on the bottom is a genetic male that's behaving as a female and lays eggs just like he's a female. What's more is, if you look at, and now I'm going to dissect these gonads for you, these are testes, and the color's going to be different because of the dye we use under the microscope. But if I slice this up, so just imagine I'm slicing a sausage, here's what it look like under the microscope. I'm going to blow this section up. Instead of sperm in the testes, this animal has eggs. So it's a male with testes, but when you give it atrazine, it makes estrogen, it causes it to grow eggs, and in some cases, the eggs get so big that they burst through the surface of the testes. So this is a male that has eggs bursting through the surface of its testes. What's more is, this wasn't just shown in my frogs and amphibians, it's been shown in fish, and it's also been shown in reptiles and laboratories around the world. So it's not just data from a single. The company will tell you it's just data from my laboratory, but these data are produced all around. So what does my work in frogs tell us about humans? Because see, we all develop in water and amniotic fluid, just like my tadpoles. And we now know that your children will be exposed to over 300 synthetic chemicals before they leave the womb, because these chemicals cross the placenta. Most of these chemicals, we have no idea what they do, but we know that frogs and humans and other animals use the same hormones when they're developing. So our problems in the frogs indicate problems in other animals as well. As far as humans, we use rats to study humans. Right? I told you, I study frogs because I'm a little boy who likes frogs. I'm pretty sure that people who study rats aren't little boys who like rats. I'm pretty sure they're studying rats to try to understand humans. And other scientists have shown that atrazine causes prostate and mammary cancer in rats when they're exposed. It causes immune failure. It causes neural damage when the rats are exposed in the womb. And the Environmental Protection Agency in the United States did some studies that I'm going to show you now that affected me more than any of my work on frogs. The EPA, the Environmental Protection Agency in the US, showed that atrazine causes abortion in rats when they're exposed because of the hormone imbalance it creates. Another EPA laboratory showed that of those rats that don't abort, the sons are born with prostate disease. The sons are born with the prostate of an old man. Of those rats that don't abort, the daughters are born with impaired mammary development, such that their breasts essentially don't grow, and as a result, their offspring suffer from retarded growth and development. This moved me more than anything because I want you to think about this. This rat on the bottom never saw atrazine. The rat on the bottom was affected by atrazine that its grandmother was exposed to. The rat on the bottom, in this US EPA study, that rat on the bottom never saw atrazine. The rat on the bottom was affected by atrazine that its grandmother was exposed to. The rat on the bottom never saw atrazine. The rat on the bottom was affected by atrazine that its grandmother was exposed to. And that's the size of the problem that we're dealing with. When I think about my daughter and my son, when I think about the fact that my grandchildren, your grandchildren, could be affected by chemicals that we're using today. You could have been affected by chemicals that we were using 50 years ago. Your grandchildren could be affected by chemicals that we're using today. We already knew that it was worse than atrazine. What's more is, this is a map some of you may have seen, a graphic. In blue now are all the companies that own seeds, that grow our food. In red are now the 4 chemical companies that own 90% of our seeds, 90% of our food. And this is why I take an issue with GMO. Because when I was in college, the promise of GMO was more nutritious rice and drought-resistant wheat and frost-resistant strawberries. 90% of GMOs, though, are to make our plants dependent on more chemicals, and that's because 4 chemical companies own 90% of our seeds, and they're using that technology to make us more dependent on chemicals that we know and they know are bad for the environment and for us. And I love Obama. Shout out to Kenya. But even under his administration, he put a Monsanto vice president in charge of the Food and Drug Administration. So the chemical companies are now working for the government to regulate, supposedly, themselves. So all this is to say, I don't believe that there's evidence that we can count on the government agencies. Certainly not the one that I... So here's a statement by my U.S. Environmental Protection Agency. They said about my work, quote, "The ultimate decision is much bigger than science. It weighs in public opinion." And that's why I think this group and what we're starting here is so important to what needs to be done. The agencies aren't going to do it. Certainly the agribusinesses aren't going to do it. And I'm happy and proud and honored to be part of this start, and I hope it really is a start. I will come back. I will relocate anywhere that I can in a place that I dreamed of as a little child to try to make important and positive things happen here. And with that, I thank you very much. It's my honor and my pleasure.